Yes.
All right, so we should probably get started to stay on time. So let's welcome Alec Groysman's presentation.
Yes. Thank you very much. First, thank you, Gabor, and to organizers, and Christine Tank for technical help. And you see on this slide, first, Josiah Wheeler Gibbs. This is an American scientist. I love him. I like him very much after my wife. And also you see traffic light. In the continuing of my presentation, we'll see the connection. I live in Israel, and I teach in this beautiful city of Haifa. I'm a chemical engineer, scientist, and educator. When I began studying at the Moscow Chemical Technological University named after Mendeleev, and took the book Chemical Thermodynamics by a Russian scientist and my teacher, Korepetians, I fell in love with the subject of thermodynamics. I understood that thermodynamics would be my specialty for future life. I specialized in corrosion of metals all my career. Thermodynamics helps me in solving many corrosion problems. When I began teaching the course of chemical thermodynamics in Israeli universities, I set the task how to present the scientific, sometimes abstract materials to students in a fascinating and memorable form. This is not a secret that students accept, like, understand, and memorize a subject better when a lecturer uses such forms as literature, poetry, music, humor, philosophy, historical comparison. I have just read in the Israeli economics newspaper that technology professions will lose their relevance with the development of artificial intelligence. I urge therefore companies look for humanities graduates with the skills of creativity and critical thinking. First, creativity increases when high-tech students, exact sciences, economics, and business administration integrate philosophy, literature, and art, history, cultural studies. Studying philosophy gives the opportunity to connect different subjects and to ask correct questions. And such integration will connect different neural areas in brains which help in effective solutions of scientific and engineering problems. A humanitarian education allows us to bring up the ethical standards of behavior of a person, a scientist and engineer. History is not only the past. History teaches that knowledge is not fixed. How do we know what we know, and how might it be otherwise? The main thing is not to know but understand what you know. My example concerns the ideal gas law PV equals nRT. Students explain well what is P, V, N, and T. On the question, what is R? Students answer that R is universal gas constant, but find it difficult to explain physical meaning of R and why the letter R is used. The French engineer Clapeyron used the experimental data of the French chemist Renault. R was named in honor of Renault. In order to explain the physical meaning of the universal constant R, we can present delta PV as a work. When we take 1 mole of ideal gas and heat it for 1 degree Kelvin, we reveal that R is the work of 1 mole of ideal gas at heating on 1 degree. Really, we can repeat the words by Albert Einstein. Any fool can know. The point is to understand. The second law of thermodynamics, entropy of the universe strives to the maximum, is the main law of the universe. It is possible to compare the action of this law both in art and in corrosion of metals as part of our existence. We take pictures by Renoir and the new boss. Then Vasily Kandinsky destroyed figurative art, increasing its chaos and respectively entropy. This is similar to the beginning of corrosion of the boss, increasing chaos owing to corrosion. The other 30 years passed. Jackson Pollock fully destroyed figurative art, and we can see entire chaos in his pictures compared with full destruction on the bus because of corrosion, not so far from my village. The famous English poet Winston Hugh Auden created the poem The Entropy Song in 1948. I will present only part of this beautiful poem. I am not being negligent, nor plain messy, no, but somebody intelligent once made a pillow. This is not a simple verse, it's a scholar's rhyme. Entropy in the universe increases all the time. From Big Bang to bigger boom, one thing just we may assume, universe roulette, or wheel spins, or the losses, chaos wins. Abstractionism in thermodynamics. Thermodynamics deals with abstract, generalized processes. Imagine a puddle after rain. The sun shines, water evaporates at constant pressure. This is a step 1, 2. Then water vapors into clouds, turn into clouds, a step 2, 3. Then clouds turn into rain, a step 3, 4. Then it rains and water drops, turn into puddle, a step 4, 1. Water cycle in nature. Let us represent this cycle as a thermodynamic cycle in the coordinates pressure, volume, PV. We do not see a puddle, the sun, clouds, rain. This is an abstract thermodynamic cycle. This is a generalization for any thermodynamic process occurring such changes, PV. Thermodynamically, reversible process, the current cycle, that Gibbs energy, entropy, ideal gas, etc., does not exist in nature and can only take place in our imagination. We use them in thermodynamics. Abstract principles of generalization is not only used in science and engineering, but in art too. Here is the black square by Kazimir Malevich, Norm Malevich, and more other painters of the beginning of the 20th century, such as Vasily Kandinsky, understood correctly the term abstraction. This black square is not abstraction at all. Abstraction is any square, according to the formula A in 2. This is a concrete real square. However, the picture ball by Pablo Picasso is a classic example of abstraction painting. The first ball is a real ball. Then Picasso removes wool and eyes. In the last end, Picasso gives only the contours of any ball which exists on the planet. This is a true abstract picture. Sadi Carnot imagined any steam engine and road. It was necessary to establish principles applicable not only to steam engines, but also to all imaginable heat engines. Thermodynamics and music, all thermodynamics and music are everywhere. They manifest in the phenomenon of life. Metal, 1,500 years ago sad. Education is modern, because green and harmony free to the depth of the south. Since the phenomenon, music is still remembered. Along the English chapter, and see on the new law, little stars. This is used by Mozart, Let me show you how students can belong chemical reaction to the tune of the Oh My Darling Clementine. Oh my ketone, and my primary in mine. You read it lots of water, and you find, and you amine. Oh my ketone, and my primary in mine. You read it lots of water, and you form and you amine. Yes, Amen.
So, Alec?
Japan.
So,
Okay. Many thermodynamic processes can be understood better if we associate them with famous musical compositions. Thermodynamics dynamical reversible processes associated with the eternal evolution, as in the flying of bumblebee while the Russian control things closely. We can imagine that this music is practically similar to the thermodynamic reversible process. Humor in education. Humor in education can and should be used. I call this jello education. Jealous from the Greek is laughter. Here are the components of humor: surprise, contradiction, paradox, ambiguity, metaphor. To understand humor, a person should know language well, be professionally skillful at suitable age, prepared culturally, intellectually, opportune moment, and humor, like beauty, is something that exists only in our minds and not in the real world. I will give you two examples. The famous thermodynamist Walter Nernst, the Nobel Prize laureate in 1920, commented in 1977, it had taken 3 people, Mayer, Joule, Helmholtz, to formulate the first law of thermodynamics. 2, Clausius and Kelvin for the second law of thermodynamics, but then he had been obliged to do the third law of all by himself, by Nernst. He added that it followed by extrapolation that there could never be a fourth law. No, this is a fine joke, as in the same 1930s, scientists understood the importance of the law of thermal equilibrium, and they called it zero law, not the fourth one. The joke is useful when you choose a supervisor. A hare plays the violin, making terrible sounds in the forest. A fox runs and demands from the hare, "Stop playing, hare, otherwise I will eat you." The hare continues playing the violin in the same awful manner. The fox says once again, "Stop playing, hare, otherwise I will eat you." Suddenly a bear goes out behind the bushes and roars loudly, "Who wants to eat my hair?" The moral: it's not so important how you play, but who your supervisor is. Duality and uncertainty and thermodynamics. Our thermodynamics in life are full of uncertainty. For example, the picture by Salvador Dali, Slave Market, with disappearing bust of Voltaire. We may see a bust of Voltaire or 2 nuns. This depends on our perception and concentration on the picture. Uncertainty in the thermodynamics is manifested in many ways to calculate the changes of thermodynamic functions, enthalpy, entropy, etc., independent of the path. Similar exists in art. Poets, composers, and artists expressed in different ways the same theme of love, struggle, or loneliness. We may enjoy both by The Kiss by August Rodin and Gustav Klimt. Therefore, art, as well as thermodynamics, gives special endless beauty, and we are able to study and enjoy both of them. Thermodynamics and philosophy. Dialectics is a philosophical concept of evolution and offers a tool to understand the way things are and the way things change. The first law of dialectics, units of opposites, points out that every object and process is made of opposing forces, sides, passive, active, hot, cold, life, death, winter, summer. Let us analyze the Gibbs-Helmholtz equations. Delta G equals delta H minus T delta S. We observe 2 opposite factors. Enthalpy, which shows the tendency for association of particles, and entropy, T delta S, which show the tendency for separation of the same particles. The philosophical generalization of the Gibbs-Helmholtz equation is based on the law of dialectics, the unity of opposites. The result is of the fighting of these opposing factors give three opportunities: delta G more than zero, delta G less than zero, and delta G equals zero. The main question of thermodynamics, to be or not to be, by Hamlet, William Shakespeare. We want to know if gold reacts with water without experiment. The American scientist Gibbs in 1876 suggested a new way of theoretical calculations for physicochemical process to be or not to be. Changes of Gibbs energy gives us a solution to decide possibility, to decide about impossibility, delta G more than zero for the reaction of gold with water. For the reaction of iron with water, we receive delta G less than zero. Corrosion can occur. There is a third possibility, delta G equals zero. This is a chemical equilibrium. We can compare these three situations with the traffic lights, to be or not to be. Therefore, this we see on Yale University, where Gibbs worked, Urim Vitamim, lies and truth. History of chemical thermodynamics gives examples of ethical principles of behavior of scientists, which can be presented as a part of humanistic education. Let us take the synthesis of ammonia from nitrogen and hydrogen gases. This is the place to tell about the tragedy of the German Jewish scientist Fritz Haber, about his ascent and downfall. Based on the thermodynamic principles, we understand the constraints of chemical equilibrium. Fritz Haber was the first to provide the industrial solution of producing ammonia and then fertilizers. His solution fed millions of people and saved many from famine and death. Fritz Haber is a classical example of a scientist who did not see or did not want to see two sides of any invention in chemistry. The same ammonia was important not only for the manufacturing of fertilizers, but also for explosives. So ammonia had the ability both to sustain life and to destroy it. Fritz Haber is referred to as the father of modern chemical warfare, as he organized and directed the first large-scale release of chlorine gas at Ypres River in 1915. During the First World War, 15,000 were killed. His wife, Clara, was also a doctor of chemistry and spoke out against her husband's research as a perversion of the ideals of science and design of barbarity, corrupting the very discipline which ought to bring new insights into life. After the chemical attack, Clara committed suicide. This was an example of the ethical dilemmas facing chemists at the time. Haber defended gas warfare against accusations that it was inhuman, saying that death was death by whatever means it was inflicted. Ernst Rutherford pointedly refused to shake hands with him when Haber came to the UK because of expelling by Hitler from Germany. During the 1920s, a scientist working at his institute developed the cyanide gas formulation Zyklon A, which was used in Nazi concentration camps. All members of Haber's extended Jewish family died in these gas chambers under Zyklon A. People do not know whether to admire him or despise him. This is the tragedy of Fritz Haber and the paradox of science with all its potential for good and for evil. Ethical, moral principles of behavior of scientists manifest, especially nowadays during the pandemic COVID-19, and will manifest even more during the creation of artificial intelligence. Science have a moral dimension. It's like a knife. If you give it to a surgeon or mother, each will use it differently.
Alec, the time is coming close.
Each will use it differently. Let me finish my lecture with the question, what will the shortage in the near future be? Energy, for you. Water, food, no. Skilled, knowledgeable specialists. Thermodynamics among them. I class in thermodynamics. And I finish this brilliant, optimistic music by thank you very much.
Thank you very much. Thank you very much, Alec, for the great talk. So before we see what we do, can we check if Ashok is present in some way? The next speaker, Ashok Sengupta.
No.
Oh, you see? Don't you have?
No.
No.
Okay, so plenty of time for questions in that case.
Gabar, why did you say me? Yes, I have several minutes. Yes. No, I have several minutes, yes. And we had to sing together.
We had to, yes. But
Okay.
hopefully there will be a next time.
No problem. Okay. With great pleasure.
Alec, can I ask you a question? Can you talk to us about
Lieb.
Goethe's elective affinities and chemistry
Yes, of course.
and Gibbs
Yes.
free energy? Gibbs free energy and Goethe.
Yeah. Oh, but I did not say in this presentation. This was many years ago when I researched, yes, connection, yeah, of Goethe's and chemistry of love, chemistry between people, among people. And I say yes, and I continue saying, yeah, that this is great thermodynamic because I show the same on Goethe's yes, approach to thermodynamics, to people chemistry, and my approach to thermodynamic of people, because this is the same in delta G. We have only 3 possibilities. Yes, this is the same in traffic lights. For example, somebody comes to young woman and say, I love you. She said, no, I don't love you. Therefore, this is red light. Delta G more than 0. There are no love. The second opportunity, he comes to the woman, I love you. She said, oh, I also love you. This is traffic light in green. The love comes, the pull comes, and they make love. And the third possibility, and delta G equals 0. This is equilibrium. I love you, but she answers, no, I don't know. I don't know, I love and know. Therefore, you may change pressure, temperature, concentration. The same person should change his, or say with his mother, your mother, yes, or invite to restaurant, bring flowers and so on.
Excellent.
It's my comparison, okay? I hope you like this.
I like it, yes.
Yes, Alec, if I may ask a follow-up on that regarding love. I mean, in physics, delta G is symmetric, so there is no one side having different delta G than the other. But in human relationships, it could be, you know, the example you said, one side could be saying yes, the other no, or the other one saying yes, and this one saying no. So there is this asymmetry, or
certainly, of course, yeah, this is great comparison with symmetry and asymmetry when we see in science and social connection. This is the same, certainly.
Thank you.
Okay.
I enjoyed this very much. Your
Thank you, Thea.
about collectives and all the way that collectives can work and how complex reactions happen. I was wondering if you could relate this to Gandhi's 7 social sins. You seem to be talking about one of them, the science without humanity. And I was wondering if you'd see any way to quantify these.
I don't deal with these. I did not deal with this problem, yes. But this is very interesting that you
Yeah,
said now.
I would think so. It talks about science with humanity versus without humanity, and commerce without morality or with morality, and
Yes, yes, yes.
wealth
Yes,
without work, politics without principles. These are all
correct, correct. Therefore, we should include our moral principles, yes, to education of young generation. Yes, moral principles, yes, because students and young scientists and engineers should know how to use their inventions. Yes, this is especially now, yes, when we penetrate into our brains, yes, with the invention, with creation of artificial intelligence. Therefore, Tia, I agree with you. This is very important, and I think that we should develop this part, yes, to show our new generation of students. Exactly in 2 weeks, we have in Institute of Weizmann of Chemical Education conference, also Zoom conference of news in chemical education. I will give this presentation, not exactly, yes, but humanitarian aspects in teaching of chemistry and chemical engineering. Yes, and this will be one of point to use in social relations.
Alec, on that question, can you explain morality to us in terms of chemical thermodynamics?
Chemical thermodynamics.
Explain morality in energy terms.
Would you be so kind as to explain exactly what do you mean? What
Can
do you mean?
Can you explain the difference between right and wrong in terms of Gibbs free energy?
Gibbs energy and
the difference between morality, right and wrong.
Reality?
Morality.
Morality. Morality. I have that also here, yes. We also can explain that more complicated. I should think about this, yes, and I think that I will find some examples about delta G. Yes, but I think that in morality, yes, in delta G we have only 3 possibilities. In morality, we have unfortunately many possibilities, I think. But also we can, in any case, we can divide. We can divide and compare, yes, with this approach. Thank you, Lee, for this suggestion. Yes, I will do this with great pleasure.
Sure.
Okay.
So there is a question from Soumya Banerjee.
Yes, please.
Yes, yes, Alec. Thank you so much for your talk. This was a great pleasure. I think my question is more of a comment. I mean, you raised the great example of Fritz Haber. I think one can also think of Oppenheimer and Werner von Braun, who were very renowned scientists whose work had impact in many different spheres, but is really a cautionary tale, as he was saying, with the rise of artificial intelligence. I mean, people are talking about ethics in AI, yet I am not aware of ethics in AI or ethics in science or morality being at least taught anywhere in any graduate curricula. I mean, is there any kind of advice that he could give to early career researchers like me who would be teaching young generation of scientists in the next few years? How should we approach this topic if there is no other class? I mean, how should we talk about this topic to our students? Thank you so much again for this. This was
yes, Shona, I fully agree with you. And in my teaching, this lecture about morality and behavior, yes, and principles of behavioral scientists or engineer, they include and they compass the main point, yes, and that is exactly the students remember forever. And of course, we can suggest many examples from whole history of science and engineering. Yeah, and even Nobel. Yes.
Yes, yes, yes.
Yes, a
Definitely.
great
Even
example
Nobel
of
himself.
Alfred Nobel.
Yes,
Yes,
absolutely, absolutely.
correct,
Thank
correct.
you. Thank you
Sherman,
so much.
yes, 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 yes.
Alec, can
Thank
I
you so
do
much.
one screen share? Can you release your screen share?
Screenshot?
Can
Yeah.
I do a screen share?
Yes.
Okay, let me
Okay.
show you.
Yes.
Just to talk about how Goethe understood morality.
What, just a moment. What do you? Moral symbols. I see.
Okay.
This is your.
So Goethe famously said in 1809
Yes.
that he says the moral symbols of nature are the moral symbols in the natural sciences, for example, the elective affinities, which are the forces between chemicals or people, which he
Yes.
says were invented and used by the great Bergman, are more intelligent and permit themselves to be connected better with poetry, connected with a society better than others, which are, after all, even the mathematical ones in the anthropomorphic. He says the thing is that the former, the chemicals, belong to the emotions, the latter, the mathematics, belong with the understanding. So Goethe said that these Bergman's affinities, which we now understand as free energies, are the moral symbols of nature and can be applied socially and chemically. Do you have a comment on that?
Yeah. This I agree fully, because even 200 years ago, yes, we see yes, exactly 2 and 10, yes, we see the same situations, yes, and I think that today we can penetrate to explain on the basis of context with neurons and how different neurons work, yes, and the brains of chemists, in the brains of poet, or in the brains of both, who can also write poems, as Humphrey Davy, yes, for example. Therefore, inside of our brains, left and right parts, yes, they're connected well. And what is very important, that this connection, yes, will give new generation forever, for much time, and they will understand that also emotions, we then can play with these and to give these students, yes, how to be, how to behave, how to study, what to study, why should we give them art, music, poetry. I think that two most in art, yes, well, most important parts, this is the poetry and humor, because humor, yes, we not so much use in our education.
Yeah, if I may comment on Goethe, just because Liv, you evoked this. I'm accidentally reading a novel by Milan Kundera. The title is Immortality, and it's very interesting how these elective affinities arise and what are the driving principles behind them, and specifically about Goethe and the young woman Bettina von Arnim. There's a very interesting discussion where apparently Goethe tries to optimize his picturing immortality by kind of engineering this relationship. So if anyone's interested, I would recommend that book. I just wanted to mention.
Sure. Feel free to post up the link in the for the title.
Sure, I will try that. I'm not sure how many questions are. I would like to ask one from Alec, and that relates to the increase of entropy in objects and in art. And I was wondering if in art people have tried to give a quantitative measure or assign a quantitative measure to sort of this randomness that you described that is increasing with the modern times.
This is exactly that it happened. It happened during all 20th century that
Okay.
entropy in art, yes, increased. And why? Because a real figurative art was destroyed. Yes, and all these modern art, or for example, abstract art, abstract picture, this is not abstract, it is not picture. Yes. Oh, great. Yes.
So here you are.
Live found. Yes. This is in Rome. In Rome. This is the conference. Yes. Correct. Yes.
Yes, can you talk about this?
Yes.
You're promoting, what did you say during this conference?
This was the conference in Rome. I think about 9 years ago. Yes, 9 years ago, where I presented, yes, how to use art and humanitarian aspects in education of scientific and engineering education. Therefore, yes, I showed that historical cases, philosophical principles, psychology, art, beauty of art, and humor should be used. And this conference was held in beautiful old library in Rome. Yes, this library since I think 15th century. You see different. This is real pictures. Yes, on the wall, and then. The same year, I organized in Israel similar conference, art, science, and technology interrelations. Therefore, I talked on the same conference about different aspects of humanitarians, this philosophy. I showed how to use them, and I published several papers on this. How to use humor, how to use music, how to use pictures, how to use different statues in this engineering and scientific education of new generation and young scientists and engineers. We can talk. My question, Lieb, yes, is anybody on this conference and Thermodynamics 2 can say about experience of use of these humanitarian aspects, using humanitarian aspects, yes, especially of art, music, literature, poetry, humor in their teaching. Yes, because I think that I teach two disciplines: materials, corrosion of metals, chemical thermodynamics, and in each lecture I suggest, in each case I suggest some humanitarian aspects, or from poetry, or from humor, yes, or from moral behavior of scientists, and so on. And this, by the way, this conference, which was held in Rome 9 years ago, yes, people from different specialty came, from art, from science, from engineering.
Yes, I'm sorry, I will have to interrupt. I really appreciate your time and giving the excellent presentation, Alec.
May I ask a simple question or a comment?
I'm sorry, we are I was told to keep on time. So if possible, we can hopefully come back to it.